So the first section, we just dealt with two-dimensional, like they're going one direction for a specific speed, then they turn and go another direction. Remember, we subtracted the ending minus the beginning vector when we did this, right? So we set up two vectors and we subtracted, and then we used that vector to find a magnitude of the velocity, and then we divided that magnitude by our time to get our acceleration. So we divided our velocity by our time. That's acceleration. Here you do have to pay attention to your units. If you'll notice as I go through this, we have kilometers per hour. I'm asking for acceleration, which I am not going to remind you on the quiz, but you should know is meters per second squared. So when you give me acceleration, you need to give it in meters per second squared. All right, that is the unit that is acceptable across the board for acceleration typically. So that's what we're gonna do on this over and over. All right, so it says Sarah is piloting a small aircraft. She starts flying east at 432 kilometers per hour. A minute later, she changes direction and is flying north at 324 kilometers per hour. Calculate her average acceleration during this 1 minute flight. So her first grouping looks like this: 432 kilometers per hour east. And then that means she's not going north or south there. Her second one is 324 kilometers per hour north. So we're going to subtract those. You start with your ending and subtract your beginning. So when you do that, you actually get a vector that looks like this. This doesn't make much difference when you have one direction, but the next one that we pull has multi-directions. So we're gonna use that process along the way. I need to find the magnitude of that velocity vector there. And so remember, magnitude is exactly the same as what we have been doing. We're going to use our square root of x squared plus y squared to get our magnitude here. So to get our magnitude for this guy, we're going to do that 432 squared and that 324 squared right there. All right. And what is your velocity here? What is your velocity when you do that? Yeah, you get exactly 540 kilometers per 1 hour. Why do you think I'm writing it weird like that instead of kph? Remember, my kilometers would normally be on bottom. 1 kilometer on bottom would mean 1,000 meters on top. My hour would normally be on top. So if my hour is on top, that would be 3,600 seconds on bottom. All right. So when I convert that to meters per second, I haven't done anything. It's just a conversion. Once I do that, to get acceleration, I have to divide by my time, which was 1 minute. However, I am not in minutes. I am in seconds, right? So this is just going to be my velocity in meters per second. I will divide that by my time, which is 60 seconds. All right. And that will give me acceleration in meters per second squared. All right, so 2 point, how many significant digits do I need? 3. So I'm not just going to put 2.5, I'm going to put 2.50 there because that will give me 3 significant digits. Anything after the decimal, right, that has a number in front of it is a significant digit. So meters per second squared, I need units on these. And I need significant digits to be correct. Let's look at the next one. The difference between this one and the one above it is that it does give me multi-directions for each one. So it gives me a starting multi-direction and an ending multi-direction. And so I am already have it broken down the way I need it. What I would recommend is that you write out, okay, so I am going to end at this guy. I'm going to start here because that's how we're going to subtract. Does that make sense? So I just write it out so that I can see and I don't subtract the wrong way. All right, so he started out with a velocity of 90 kilometers per hour north and 36 kilometers east. So 90 north and 36 east, which one goes first? The 36 goes first, the 90 goes second. Remember, east-west is typically my X, north-south is my Y. It won't make a difference so much if you keep it in the same order, but if you don't, then you may confuse yourself. So you may want to stick to east-west is my x variable, north-south is my y variable. It says after navigating a curve for 8 seconds, his velocity becomes 54 kilometers north. So that's my y, and 108 kilometers east. That looks like that. This is how you're going to subtract. It didn't matter on the first problem because you only had one north and one east. And so your velocity vector ended up being the same no matter which way you did it. But here you're going to need to subtract. So I'm going to subtract down like this to get my vectors. All right, so my new vector here is going to look like this. 108 minus 36, 54 minus 90. If I wanted to get direction from this, right, then I would say he's going east and south, right? Does that make sense? From his original position. But we don't have to worry about that just yet. What I do need to do is get the magnitude of this vector. I'm going to do that the same way I did above. I'm going to say the square root of that 72 squared plus that 36 squared is going to give me my magnitude here, which is going to be my velocity. You should get about 80.5 kilometers per every 1 hour. Again, what do I need to do to him? I need to convert. And once again, you're going to see this conversion over and over. Kilometers is in the top, it needs to be in the bottom, which means 1,000 meters will be in the top. An hour needs to be in the top, which means the seconds need to be in the bottom, 3,600 seconds. That will be my velocity of this guy. To get my acceleration, I need to divide by my time. So divide by that 8 seconds. And you will have your meters per second squared. Which for this one, when you give me 3 significant digits, I believe you get about 2.80 meters per second squared there. For these are just like your homework. You have a change in x, you have a change in y. In that, you have your initial velocity for x. Remember, for these, we are just horizontal launches here, meaning the y has no initial velocity. If you see your formulas will talk about an initial velocity for y, but that's just 0 for us right now. We're not putting any initial velocity up or down, all right? So my change in y then is just gravity and time that's affecting that. So a humanitarian aid drone is programmed to drop medical supplies from a height of 80 meters above the ground. If the drone is moving horizontally at 54 kilometers per hour, how far horizontally will the supplies travel before hitting the ground? Couple things. You want to label some stuff. 80 meters above the ground is going to be how far that's going to drop, meaning it's going to drop 80 meters. Moving horizontally, well, that is going to be my initial velocity for x. So velocity for x is going to be 54 kilometers per hour. Again, I'm going to change this to meters per second because they gave me my height in meters, right? And so I'm going to change this with my conversion, the same exact conversion I have been doing the entire time. So we're going to say 1,000 meters to cancel out the kilometers, 3,600 seconds to cancel out the hours. All right. Which means he is going 15 meters per second there. All right. In order to figure out how far it will go, we look at this. Change in x is how far. We need an initial velocity, which we have, but we need a time. All right, we're going to use our height to get our time. We're going to use our height to get our time. So we're going to say, well, I know my change in y is going to be 80 because that's how far it's dropping. And I know what gravity is because that is a constant. I just need my time. So think about what you're doing here. Multiply by 2, just so you get an idea for what happens in your calculators. Multiply by 2, divide by this gravity. right? And then you're going to have to take the square root of that. Now you can do all of that in your calculator. All right, or you can do the 2 times the 80 divided by the 9.81, and then in your calculator you can do your square root and then grab that answer button, right? And it'll grab the answer of whatever that multiplication division was for you. When you do that, you should get about 4.04 seconds, something like that. And now we really have everything we need to figure out our change in x. Our change in x is what we're looking for. We have our initial velocity of x, that's 15 meters per second. We have the number of seconds that we will be traveling that far, and we just multiply. When you multiply, you should get approximately 60.6 seconds. However, what significant digits do I need to use for this problem? Digits. So remember, when you're multiplying, you're going to use the least amount of significant digits. We multiplied by that 54. So this needs to be 61 meters. That's 2 significant digits there. So for this next one, during a rock climbing expedition, a climber accidentally dislodges a small rock from a cliff. If the initial velocity of the rock was 5.1 meters per second and it lands 25 meters away from the bottom of the cliff, how high was the cliff? So in this case, we actually know change in x, which is 25 meters away. We also know the initial velocity of x, which was 5.1 meters per second. What we do not know and what we want to know is the change in y, because the absolute value of that change will be how high the cliff was. Okay? So we need the time in order to figure that out. We have everything we need to solve for time. We know that the change in x is going to be the velocity of x multiplied by time. Fill in what you know. We know the change in x was 25. We know the velocity was 5.1. If you divide, you will get your change in time, which is approximately 4.95 seconds when you calculate that. 25 divided by 5.1. So now we're going to use that gravity problem. We know that it fell for 4.95 seconds before it hit the ground. So then my change in y is going to be 1/2 times my gravity times my 4.95 seconds squared. All right. So when you do this problem, I think you get like 117.7, something like that. I don't have it written down. Approximately 117.7, somewhere around there. Technically you get negative, but remember when it says how high, we're not going to say the cliff is negative 117 feet high. That's weird. Okay. The other thing is, how many significant digits do I need for this? I need 2 significant digits. What would this look like if it were absolute value, because we're talking about how high, and 2 significant digits? 120 meters is 2 significant digits, right?